I'd like to talk a little bit about using the unit circle. And before anything else, I want you to remember that on the unit circle, your sine is your y value, cosine is your x value, tangent is y over x, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So those are really important to know. So let's do some examples. And you'll notice for the first set of examples, I'm not actually going to give you a unit circle. We're going to kind of draw a mini unit circle in order to evaluate them. So you might notice that all of these examples that I gave you are in radians. And the reason that they're all in radians is because I want you to start thinking in terms of radians. They're a little bit harder for people to understand. So my first one, I have cosine of pi. You can remember this one of two ways. You can either remember that pi is equal to 180, or you can remember that if you go all the way around, that's equal to 2 pi. So that means that pi would be halfway around. It would be from from here to there. So whatever works for you is fine with me for this one. Just do whatever is the easiest for you to remember. So when we have a problem like this, without even looking at a unit circle in front of you, I want you to be able to kind of draw it out. So my first thing is, if I were to have cosine of pi or cosine of 180, that angle would look like this. And I want you to remember on your unit circle what that point is. Now remember, it's going to be 1 away from 0, 0, because the unit circle always has a radius of 1. So that point is at -1, 0. Remember that cosine is our x value, so my answer for this one is going to be that x value, which is -1. We're going to do the same thing for number 2. So number 2, again, you can there's a few ways that you can remember this. This is 3/2 pi. Remember, if you go all the way around, it's 2 pi. 3/2 is actually 1.5 pi. It actually goes right here. This is one that you probably should just remember. You can also remember that it's 270. So it's going to be right down here. And if I were to find that point on the unit circle, that would be 0, -1. That means that my sine value is -1 because I'm looking at my y value. 3 is a little harder for two reasons. The first thing is that we're looking at cosecant, not sine or cosine, and we're also going to be using a negative angle. So -3 pi over 2 is going to be actually the same thing that I just drew, the same type of angle, except in the opposite direction. So I'm going to start going clockwise, and I go around that much. So then this is my angle. If you want, you can think of it as finding a coterminal angle of positive 90 degrees, but you certainly don't have to think of it that way. I think for me it's easier just to look at it as going in the opposite direction. This point is 0, 1. So now cosecant is 1 over y. So it's going to be 1 over 1, which just gives me 1. For number 4, this is another one where you might want to try to find a coterminal angle. There's a few ways to do this. Or the other way to do it is just to notice that 6 pi means I have 2 pi, so I'm going around 3 times. So I go around, this is 2 pi. If I go around again, this is 4 pi. One more time is going to be 6 pi. So then I end up back where I started from. This is the point 1, 0. Secant is 1 over cosine. Cosine here is going to be my x, which is 1. So I have 1 over x, or 1 over 1. And my answer for that one is also 1. The last one, I gave you one of these pi over 4s. So I want you to kind of keep in mind that a pi over 4 thing is going to be, for all of them, if it's over 4, it's in the exact middle of my quadrant. It's going to be one of those ones that's a multiple of 45 degrees. So if you have a pi over 4, you can remember that it goes in the middle. This one is equivalent to 135 degrees. One thing that you can remember, if you have something over 4 on the unit circle, it will always have these two values as x and y, radical 2 over 2 and radical 2 over 2. You then need to just figure out what your signs are. In this case, I'm in quadrant 2. So my sign for the x is negative, my sign for the y is positive. And since I'm looking at sign, I choose the y value, which gives me radical 2 over 2. So for the next few, these are a little more challenging, and since we're just starting out with them, I am going to give you the unit circle. So for number 6, secant of 2 pi over 3, this one's pretty nice because 2 pi over 3 is on the unit circle. We can see it right there. I know that secant is 1 over cosine, so I'm going to do 1 over negative 1/2. That actually ends up just being negative 2. For number 4, I have tangent of negative 7 pi over 4. This one's a little bit more challenging because we actually are going to be going in the opposite direction. So 7 pi over 4 is right there. You can kind of imagine what it would look like if we were to go like, so positive 7 pi over 4 would be in this direction. Negative 7 pi over 4 is going to be that same distance, but it goes in the opposite direction. A little hint for these. One thing you're going to find is that the 7 pi over 4 is going to be exactly a reflection of its negative corresponding angle over the x-axis. So that's going to be a little bit helpful if you think of it that way. So negative 7 pi over 4 is going to be just the same. It's going to be a coterminal angle with pi over 4. Another way that you can do this type of problem is by finding a coterminal angle. You can find a coterminal angle by adding 2 pi. If you add 2 pi to negative 7 pi over 4, you will notice that you get pi over 4. So that's another way that you can do that type of problem. I do want you to notice that I am using only radians. You also can do these problems by converting to degrees. However, throughout all of calculus and any other math classes that you take after this one, you will be using almost extensively, you'll only be using radians. So I want you to start trying to think in terms of radians. If you take physics, you'll be using degrees only, but calculus is almost all radians. So if you can start thinking in terms of radians now, it'll help you for the future. Okay, so sorry, that was a little tangent, no pun intended. So tangent of negative 7 pi over 4 is going to be equivalent to tangent of its coterminal angle, pi over 4. You'll notice we have radical 2 over 2 and radical 2 over 2. So if you divide those out, you just end up getting 1. For number 8, I have cotangent of negative 7 pi over 6. Go ahead, pause, and try this one on your own. So for this one, negative 7 pi over 6, there's going to be 2 ways to do this. You can either try to draw the coterminal angle, or draw the angle. It's going to look like that. Or you can find a coterminal angle by adding 2 pi. If you add 2 pi, you get 5 pi over 6. So either one is going to work. When we do that, remember cotangent is going to be equal to x over y. In this case, we get negative 3, radical 3 over 2 divided by 1/2. There's a few ways to do this next part. I always like to think of it as if I'm multiplying this whole entire fraction by 2 over 2. When I do that, I'm left with negative radical 3 over 1, which is just negative radical 3. So for number 9, this is another one where you don't actually see this specific value on the unit circle. So you'll notice that if I look at all this stuff over 3, I only go up to 5 pi over 3. You probably will want to do the same thing that you did previously and find a coterminal angle. This one we're going to be subtracting 2 pi. When you do that, you find that your coterminal angle is pi over 3. So now we can do cosecant of pi over 3. And cosecant, remember, is the reciprocal of sine. At pi over 3, my sine, my y value, is radical 3 over 2. So I get 2 over radical 3. I'm actually perfectly fine if you leave it as 2 over radical 3. And if you take calculus next year, it's totally fine if you don't rationalize your denominator. However, I do want you to keep in mind that oftentimes, like in AP Calculus and sometimes in college level classes, oftentimes you have a multiple choice test. And in the choices that you would have, this answer would be rationalized. So I'm going to show you how to rationalize the denominator. Hopefully you remember how to do this. You would do that by multiplying by radical 3 over radical 3. That gives me 2 radical 3 over 3. So I will accept either answer, but keep in mind if it's multiple choice, you need that second answer. So just make sure that you're aware of that, but feel free to not bother rationalizing your denominator.